This video covers everything you missed in class today if you were absent on Wednesday, February 16th. First, you need to open the ClassKick link above this video, and on slide 1, complete the Do Now. So open ClassKick, pause this video, and complete the Do Now on slide 1. Remember that when we're talking about exponents, that is the little numbers above the big numbers, that little number, the exponent, tells us how many times to multiply the big number. For example, 9 squared, or 9 to the second power, means we multiply 2 nines. 9 times 9 is 81. In example 2, we have 4 raised to the third power, so we're multiplying 4 3 times. I know that 4 times 4 is 16, times a third 4 means I have to multiply 16 times 4, which gives me 64. Similarly, if I have 3 to the fourth power, I know I need to multiply 3 fourths. 3 times 3 times 3 times 3, which is 3 times 3 is 9. I have 2 3s left over. Then I'll multiply 9 times 3, which is 27, and I have 1 3 left over. And then I'll multiply 27 times 3, which is 81, excuse me. And that's how we solve problems involving exponents. Today's learning target is I can write and solve an expression with a variable to represent a real-world situation. The purpose of today's lesson is to start reviewing some key concepts that we'll be seeing in Unit 6, working with expressions and equations. Your next step is to complete Slide 3, Algebra Talk, when x is 6. For each of these problems, if x is equal to 6, what is x plus 4, 7 minus x, x squared, and 1/3 x? Some of the equal signs got cut off, but that's what those say. Go ahead and pause this video and answer slide 3. Let's look at x to the second power as an example. I know that I'm trying to find x to the second power, but x is 6, which means what this problem is really asking is 6 raised to the second power, or 6 times 6, which I know is equal to 36. In any of these problems, all they're asking you to do is replace the x with the number 6. They're telling you what x is equal to. So, for example, if I have 1/3 times x, that becomes 1/3 times 6, because x is actually equal to 6. 1/3 times 6 is 6 over 2, because I multiplied the whole number times the numerator. 6 over 3, and 6 over 3 is 2, because I can divide 6 into 3 groups of 2. Let's take a look at slide 4. Question 1. Lynn set up a lemonade stand. She sells the lemonade for 50 cents per cup. A. Complete the table to show how much money she would collect if she sold each number of cups. B. How many cups did she sell if she collected $127.50? Be prepared to explain your reasoning. Well, we know that Lynn is selling each cup for 50 cents, which means if she sells 12 cups and we multiply 12 times 0.5 or 12 times 50 cents, we can see how many cups she sold. 12 times 50 cents is, of course, 6, which means that she collected $6 after selling 12 cups. We can follow the same steps for 183. We can multiply times 0.50, because again, that's the cost per cup. And 183 times 0.50 is equal to $91.50. And so that's how much money she earns if she sells 183 cups of lemonade. Now, the next box on our table says that she's selling C cups of lemonade. C is a variable that represents any number of cups. What we know about C is that no matter how many cups of lemonade she sells, she is always multiplying the number of cups times 0.50. And so we can write this box as 0.50C. All that this says in the yellow highlighting is that for any number of cups, which we are representing with C, the letter C, we can always find total cost by multiplying times 0.50, because again, that's the cost per cup. That's all that this expression 0.50C tells us, but instead of writing out this whole sentence, we can summarize the table by simply saying 0.50C. Question B says, how many cups did she sell if she collected $127.50? This time, we know this row of the table, 127.50. We need to figure out how many cups of lemonade were sold if she made $127.50. I know that some number C, whatever the amount of cups is, times 0.50 equals 127.50. So I can use my inverse operation to solve. 127.50 divided by 0.50 will show me that she is making 255 cups. And that's how many cups she needed to make to sell to make $127.50. I want you to pause this video and try question 2. It's very similar to question 1 in that you're completing a pattern in the table. You can check your work for question 2 in the PDF slides in today's folder in Schoology, where I've uploaded today's notes. Let's look at slide 5. On slide 5, you're being asked to write some expressions to represent different situations. For example, if Claire is 5 years older than her cousin, how old would Claire be if her cousin is 10 years old, 2 years old, and this right here says n years old. N meaning any number of years. We know that if Claire is 5 years older than her cousin, if Claire's cousin is 10, Claire would be 15. If Claire's cousin is 2, she would be 7. We're just adding 5 to how old Claire's cousin is so we can see Claire's age. Notice that n is any number of her cousin's age. Could be 1 year, 10 years, 50 years. No matter what n is, we're always going to add 5 to find Claire's age. And so our expression to represent the situation is n plus 5. Now, if we have to work in reverse, if we know Claire's age and we need to find her cousin's age, instead of adding 5, we'll subtract. We have Claire's age of 12, we take away 5 years, and we know her cousin is 7 years old. You're responsible for completing questions 2 and 3 and 4 on slides 5 and 6. They're all answered just like question 1, which I just showed here. When you're finished with slides 5 and 6, you have a lesson summary on slide 7 that will help you review today's lesson. Slides 8 and 9 are optional, but you do have an exit ticket in the main folder for today, so make sure you take a look.